croeso pawb. Diolch am ymuno heddiw yma. Thank you for joining today. So I'm Holly. I'm DTA Wales's Comms and Events Officer. So those of you who don't know Egin or DTA Wales, those of you who may not have been on one of these webinars before or involved in any of the projects, DTA Wales are an independent and not-for-profit membership organisation who supports social enterprises, businesses, charities and communities across Wales to thrive. And Egin is one of DTA Wales's biggest projects. So Egin is a programme that empowers communities across Wales to take their first steps towards tackling climate change. And we do this through providing resources, events, mentorship, and webinars such as this one. So it's a very, very quick run through of what we do here at DTA Wales and Egin as a spin-off programme. I'll hand over to Elfed to talk about all things insulation.
Thank you, Holly. Thank you. I'm an independent consultant. I do help community groups with insulating buildings, with renewables, with energy efficiency measures. And I also work on the Egin project, running the Community Buildings Hub. I just wanted to very quickly show you a link to the Community Buildings Hub, if I can remember how to do this. Share. I'll just share my desktop. 1 second. I've recently updated my my computer, and it's now needing me to click a few things to share. So this is the Community Buildings Hub website. We can put the link in the notes shortly, in the chat, sorry. This has a number of different articles on a number of different topics within foundations. You've got building maintenance, behaviour change, how to actually fund some of the measures you might want to do. The section we'll actually be dealing with today is within the technical section. It's this document here on insulation. So I will be going through some of the topics in there, but obviously if you want to look at it in slightly more depth in your own time, you can go on the Community Buildings Hub, go into the technical session, and then read the insulation document. Okay, I'll just start my presentation. Okay, hopefully my insulation presentation is showing up for you. Thank you. So these are the topics we're going to look at in today's session. So how does insulation work? How does it save energy? What are some of the insulation material types that we could use on our community building projects? Should we do internal insulation, maybe external insulation? We could even do potentially cavity wall insulation, so insulation within a wall. What are the advantages and disadvantages of all these different types of insulation? Another really important question is how much insulation should we put? We all, would love to put, 2 feet of insulation around our buildings, make them nice and warm and really cheap to run, but that's not always practical. So what's sort of good targets in terms of the amount of insulation we might want to put on our building? How does it save us money, and how much money does it save? Particularly if we're funding this ourselves, we want to know how quickly we're going to get that money we invest in insulation back. We'll also look a little bit on thermal bridging. This is a slightly more technical topic, but we will come back to this in a bit. And then I'll show you an example of a community building that I've worked on where we've insulated the building to a reasonably high standard. There's also time at the end to ask any questions. But obviously, as we move through the materials, if there's a particular burning question and you think this can't wait to the end, please do put your hand up, and I'm more than happy to sort of answer a few questions as we go as well. So how does insulation work? We measure how effective something is at insulating our building as either a U value or an R value. And these two are sort of related. If something is a good insulation, then its U value will be really, really low. Or if it's its R value, its value will be really, really high. Both of these values show the same thing. But if we're looking at a U value, the lower the value, the better it is at insulating. If we're looking at its R value, the higher the value is, the better it is at insulating. If we look at a solid stone wall, the types that we see sort of all over Wales, maybe old chapel buildings, rows of terrace housing with solid stone walls, it can have a range of values and it depends on the thickness of the wall. But typical values we see for a 2-foot thick solid stone wall with sort of concrete grout acting as pointing is we would say that this has 1.8 watts per meter squared Kelvin. What this means is 1.6 watts will escape through 1 square meter of that wall, multiplied by the difference in temperature between inside and outside. So if it's freezing outside, if it's 0 outside, and it's 20 degrees inside the house, then we multiply 1.6 times 20 to give us 32 watts will escape through 1 square meter of wall. We tend to use -3 in most parts of Wales because this is what is universally acknowledged as the sort of lowest typical temperature, except for really, really cold years that we would experience in Wales. So we use -3 for most areas of Wales as being the lowest temperature when we're designing insulation solutions. So in that case, through a solid stone wall anywhere in Wales, we would expect to lose 37 watts of heat through a 1 square meter section. So if I look on the wall behind me, if I measure 1 meter across, 1 meter up through that square, we would lose 37 watts of heat on the coldest day of the year. But obviously our building isn't 1 square meter in size, otherwise it would be a very, very small building. So what we now have to do is to measure the walls in our property. So in this example I've got here, we've got a large room, 10 meters by 5 meters, and the ceiling height is 7.5 meters high. So in this case, we would say that the walls have 75 square meters of surface area. So if we want to know how much heat is escaping through the walls, we multiply 37 watts per square meter by 75 square meters. And then this gives us a final figure of 2,760 watts of heat that's escaping through the walls of this building. What we might then want to do is to insulate the walls to reduce the heat that's being lost through the walls. This is a property, and I'll give you more details about this property later, that I insulated in Trawsfynydd. It's an old stone chapel building with 2-foot thick solid stone walls, exactly the types of walls I've just been describing. And we added 100 millimeters of wood fiber insulation to the walls of this building. As you can see, the insulation is being applied internally because we're in the Snowdonia National Park. They wouldn't let us apply the insulation externally. So we're applying it internally. So if we take this example of this building, if we add 100 millimeter of wood fiber to the wall, there's a calculation we can then do to work out how much this reduces the U value of that wall. I've done the calculation here for us because it's a somewhat complicated calculation, but this will reduce the heat loss through the wall down to 0.3 watts per square meter. So if we do the exact same thing as we did for the previous example, we multiply that by 75 square meters of surface area and multiply it by 23 degrees, the difference between -3 and 20. We can now say that by insulating the walls in this property, we've reduced the heat loss down to 520 watts of heat. So we've reduced from 2,700 and something down to 520. So we're losing a lot less heat now through the walls of this building. We can do exactly the same thing for the roof. An uninsulated roof, it has a wide range of values. It depends on the material. So if it's plasterboard, are there wooden joists? Are there sort of any lime maybe that's been put up in the attic void? Is it ventilated or not? But we could say that a typical ventilated attic space with no insulation at all could have a U value of 4.6 watts per square meters. The roof is 50 square meters, 5 meters by 10 meters, same as the previous example. So doing the same calculation again, we would say that the ceiling loses 5,290 watts of heat. Building control today, if you were building a new property, would tell you to put 300 millimeters. Well, they actually say 270 millimeters of insulation, but it tends to come in 100 millimeter rolls, so you would typically put 300 millimeters in. So if we added 300 millimeters to this example, we would take the U value down from 4.6 to 0.13, which is a substantial reduction in heat loss. And the amount of heat being lost through the roof in this case would go from 5,290 watts to only 150 watts, which is a massive saving. Usually, the first bit of insulation people tend to do in their homes or in their community buildings is loft insulation, and this is why. The wall insulation example, you lost 100 millimeters of room. In the property, it's massively disruptive. Nobody can use the property while you're doing that. You have to replaster, redo all the electrical work. But bringing 300 mil of rock wool or wool insulation in this particular example up into an attic void is reasonably cheap, reasonably easy, not very disruptive at all, and has a massive effect on the heat loss of the property. Which is why we don't tend to see many properties with no loft insulation at all. The example I'm going to show you at the end was the building with no insulation at all in the loft. But what we might see is a building with, very, very poorly applied, maybe 50, 60, 80 mil of insulation that was done 15, 20 years ago. That would also have a big effect on running costs to add extra insulation into such a property. We can also calculate the floor heat losses. The floor, much less heat is lost through the floor. One of the reasons why is because the earth underneath the property is actually significantly warmer than the air temperature outside of a property and tends to be constant through the year. And it tends to be the bit sort of at the very edges of a property, the bit that's closest to the outside air where we lose heat out. But I would expect maybe, 1,000, maybe 1,500 watts of heat could be lost through the floor. And again, adding insulation to the floor might reduce that down to, again, it depends how high you can sort of build up the floor on top of the existing floor. It might take it down to maybe 500 watts again. So it's a significant saving, but it tends to be much less than with both roof and wall insulation. So this is an example of some loft insulation. This particular example is quite badly installed, but there is actually plenty of insulation up in the loft. It's just very, very uneven. We can see there's sort of the picture on the right there. There's a massive mound of insulation in one part, and hardly any in the bits in the bottom left. And then in the picture in the middle, they haven't applied much insulation into that middle section around the wall. So there's plenty of insulation up in this attic. It's just very, very badly installed. And we would usually say that any gaps in insulation in a property, either wall, floor, or in the roof, will have the effectiveness of the insulation. So this would probably have on average maybe 200 millimeters of insulation, but because of all these gaps, this would be as if this property had only 100 millimeters of insulation. And what I would like to see as an energy assessor in this property is the insulation laid out nicely and neatly in rows, sort of going maybe across for the first layer and then down the room in the second layer with all the layers overlapping and with no gaps between them. And that was my recommendation to to this particular group was to, relay this insulation and make it slightly neater. So we could say for this little small example here, a small building 10 meters by 5 meters, that there could be as much as 8 to 10,000 watts of heat loss through the walls, roof, and floor. And we could fairly, conservatively reduce this down to 1 to 2,000 watts of heat losses by insulating the walls, insulating the loft, and maybe putting a minimal, maybe 30 millimeters of floor insulation so that we don't sort of raise the level of the floor too much. Now, there are other heat losses in a property through windows, through doors, through drafts, and things called thermal bridges. But it does give you a rough idea of how much potential energy you can save by insulating a property. Translating this into money, if a room needs 10,000 watts to stay warm, if there's 1,000 watts of heat losses through the walls, then we need to add 10,000 watts of heat into that room to keep it warm. If we've got electric heating and we're paying 30 pence per kilowatt, then this is actually costing us £3 per hour to keep the room warm. This doesn't include getting the room warm before you arrive. This is just keeping it warm while you're in the property. Now, if we've reduced the heat losses down to 2,000 watts of heat losses, the hourly running cost is now 60 pence per hour. So we've reduced it down to 20% of what it would have been before we insulated the properties. Obviously, we're not counting some of the other heat losses here. They will also add to the cost as well. But just the heat losses through the walls, the roof, the floor, we will have saved £2.40 an hour in running costs for this particular example property. If your property is 5 times the size of this, and it's a similar type of property, then obviously your running costs have gone down from £15 an hour to £3 an hour, which is a significant saving. The next question is, what materials would we want to use to insulate our building? Now, there's a massive array of different materials we can potentially use. PIR, which people commonly refer to this as Kingspan, but it's important to note that Kingspan is a brand, not a type of insulation. Just like we call a vacuum cleaner, we call it a Hoover. Kingspan is just a make of polyisocyanurate, PIR, insulation. It's a plastic-based insulation, so it's a synthetic material created out of crude oil, essentially. It's used to create a plastic-type material, which is also a very good insulant. Polystyrene is another such material. It's a synthetic insulation material. Both of those materials are very, very good insulants, very, very cost-effective, but it's important to note that they're not easily recyclable. And so it's just like we have plastic waste, it's entirely possible that in 50 years' time, we'll have a lot of insulation waste when people are potentially sort of changing the insulation in their properties. There's also some more exotic materials like aerogel or vacuum panels. These are, again, very, very, very good insulation materials, but they tend to be extremely expensive. So I don't normally recommend them for properties. There's a particular type of solid rigid insulation called compact foam. This is great to use around windows because it has the same mechanical properties as wood. So you could use it potentially to build a box around a window, for example. Then we've got, rock wool, which is a type of spun rock, which is used as an insulant. Recycled materials such as recycled glass or glass fiber insulation. And then we also go into more natural materials we can use as well. I'm personally a big fan of wood fiber, wool insulation. I mean, Wales is full of sheep, so we might as well make some use of some of the natural materials we already have here. And wool insulation is one great use of spare wool. There's many, many, many other types of insulation we could potentially use as well. And all of these have advantages and disadvantages. So when I look at a building project, I might want to consider, the naturalness of a material. Synthetic insulation materials are great. They're very, very cost effective. They save loads of energy, and I regularly use them on building projects. But I do have a little bit of a soft spot for more natural materials like wood fibre and wool. And I sort of worry about some of the long-term effects of using more synthetic insulation materials in terms of the recyclability and what do we do when these materials reach the end of their life. We might want to consider the material's carbon footprint, particularly the ones that are derived from petrochemicals. We might also want to consider, does it match the aesthetic of a particular building? Maybe we've got an old grade 2 listed church building. Do we really want to be putting, synthetic insulation materials with plasterboard on one side and sort of changing, some of the, we might look at a wall and think it's sort of wavy and all over the place, but there's sort of also a bit of a charm to that. And also, using different material types will change the aesthetic of the building to some degree. Wood fibre can flex a little bit, so you can sort of keep that, some of those sort of, bowing out of some walls or waviness or sort of roughness of some wall types. We might also, particularly in Wales, want to consider moisture in our walls. We get a lot of rain, particularly in winter, quite a lot of driving rain, which can find its way into buildings. Solid stone walls are naturally vapor open, so they allow water vapor to pass through the wall. And if we put a synthetic insulation material either on the outside or the inside of that, we are actually changing how the vapor moves through the wall. We're essentially blocking one side of that vapor open material. Wood fibre, wood wall boards, rigid wall boards. Some synthetic materials also will allow vapor to sort of move through the wall, keeping some of that moisture movement, as it was before. So it's important to consider some of those issues as well. And then obviously the cost of the material is another consideration. It's very well, saying you should use, spun unicorn hair for the insulation for your building, but that's going to be a very, very expensive insulation solution, and we're all working to budget. So that's another consideration we should keep in mind. And then finally, is the material fire retardant? Most insulation materials are, but there are some materials you might not when you use, for example, on high-rise buildings, as we saw from the awful Grenfell tragedy. So keeping some of those sort of fire retardant concerns for certain building types is also important. Most insulation materials will have a certain degree of fire retardantness. Wood fibre, for example, does have a fire retardant added to the material. Other materials such as wool are naturally fire retardant. So considering that in your building project is also important. So we've got a sense of how much we want to insulate the building. We've decided on the material. Do we insulate inside the building or do we insulate outside the building? So external wall insulation, as is obvious, goes on the outside. It's typically mechanically fixed into your wall. If your wall is a bit uneven, there might be a scratch coat of some sort of plaster, maybe a lime mortar added first to level out the wall, and then external wall insulation is added to the property. There's lots of advantages of doing external wall insulation. One is that the bulk of your wall is on the inside of the property. So it can act as a little bit of what we call a thermal buffer. It'll soak up some of the heat in the room in the summer, and it'll release it, maybe as nights get colder. So it sort of stops wild swings in temperature in a building. It sort of absorbs the excess, and then as nights get colder, it starts releasing that back into a room. But the massive disadvantage of it is that it does dramatically change the outside appearance of your property. I'm involved in a project in Blaenau Ffestiniog at the moment. Blaenau Ffestiniog is a UNESCO World Heritage Site. So we didn't even bother asking if we could do external wall insulation because we knew the answer was no. Similarly, the project I did in Trawsfynydd is in the Snowdonia National Park. We were reasonably confident they'd say no, so we just planned it as internal insulation from the start. So I would say internal wall insulation works very well as well. You do have to be a bit more careful in terms of material choice. I'd be very hesitant to use Kingspan or polystyrene on an internal face of a typical solid stone wall of the type we have here in Wales. In this particular project, I was using wood fibre on the walls to keep that sort of vapour movement going through the walls and to stop moisture building up behind the insulation. And because whenever that happens, it always finds some way of getting into the room. And then there's a similar issue with loft spaces. The example I gave you with loft insulation earlier is what we would call a cold roof. So we had on the top floor, maybe on the plasterboard between the ceiling and the attic space, we would put rock wool or maybe wool insulation rolled out at ceiling level. And we call this a cold roof because the roof itself then is outside of the thermal envelope. The heat is kept inside the property, but the actual roof void and the attic space itself will get very, very cold. But the example on the right of a warm roof is where we actually insulate up along the joists so that the attic space itself is also a warm space. There's not massive benefits between one and the other, really. If you think you might eventually use the attic space in your community building, it might be worth doing a warm roof so that the space is available and within the thermal envelope of the property. But loft insulation is so cheap and so easy to install. You know, even a competent DIYer would be able to easily lay insulation in a loft space. So cold roof has a lot of advantages in terms of cost and ease of installation, whereas a warm roof is more expensive and required skilled labour to put in place. So how much should we insulate? Yeah, very good question. In theory, you can put as much as you like. If you want 3 foot of insulation on your wall and you've got space for it and you've got budgets to pay for it, go for it. But there are some caveats to this. And the main one really is that as you add more insulation, the actual benefits you get is less and less and less. So the first millimetre is what gives you the most bang for your buck, if you like, and the last millimetre of insulation you install is what gives you the lowest amount. So in our previous example, let's say we had a wall, 4,600 watts of heat loss in this particular wall. If we add 25 mil of wood fibre, that heat loss goes down to 2,200. So a 2,400 watt saving on this particular property. If we add another 25 millimetres, it takes it down to 1,500. So the next 25 millimetres is only saving us 700, less than half of what we got with the first 25 mil. The next 25 is even lower. We only save 380 watts. And then the final 25 to take us to 100 mil only saves us 260 watts. So each additional 25 millimetre block of insulation saves us less and less and less heat as we go. So we might say, okay, well, 25 millimetres gives us the most effect, so let's just put 25 millimetres on there. That would work best, right? Well, that's again not always the case. Remember that the material cost is only a small part of the overall cost of insulating the property. I would argue that probably the labour costs is what is the largest cost in terms of insulating a property, and whether they put a 25 mil sheet of insulation on a wall or a 100 mil sheet of insulation on the wall, the labour cost will be roughly the same. Usually as well, as you add larger and larger bits of insulation, the actual cost per millimetre of insulation drops. So in this example here, I got these prices off Insulation Superstore, a popular online website. A 25mm Kingspan board roughly works out as 52 pence per millimetre thickness you have. Whereas when you go up to 100 millimetres of thickness, the cost per millimetre is 34 pence. So we can see here that as you have thicker and thicker bits of insulation, the actual cost per extra millimetre goes down and down and down. So if you put 25 millimetres on a wall, or you priced up putting 100 millimetres, I wouldn't expect the cost to be 4 times as much. So it's still worth adding more insulation than you know. It's not a case of going for the small amounts to give yourself the biggest energy savings. It's about sort of working out where you want to be in terms of your running cost, and then working that back to a depth of insulation. The other thing to consider is, if you did add 25 millimetres of insulation today, you would probably never ever add more, right? Energy costs would have to be astronomical for you to consider the disruption and the cost and the hassle of adding another 75 millimetres in future. So in terms of future proofing, it's perhaps also better to consider putting slightly more than you need, as long as your budget will cover it and as long as the payback period is good, just because you know that you'll probably never ever want to do this ever again after having gone through a big building project. The other thing we might want to consider when insulating a property is the dew point. When we're insulating internally with a vapor open material like wood fibre. So in the first example on the left, this is a solid stone wall, 2 feet thick, 20 degrees inside, 0 degrees outside. Water vapor will naturally move through that wall. And as it moves from inside to out, when it reaches probably around 12 degrees, might be slightly higher, it'll condensate and it'll turn into a liquid, and then it'll find its way out of the wall somehow, through cracks or gaps in the wall. If you add internal insulation, what you're doing is you're moving the dew point closer in to the building. So the second example here in the middle is of 100 millimetres of wood fibre. The dew point now is still inside the wall, but it's very much, inside the property. It'll hopefully still find its way out, but we're sort of at the limit here of what we can do in terms of internally insulating a solid stone wall. The example on the right, 300 millimetres of wood fibre, the dew point is now inside the wood fibre, which means it's inside the building. It's potentially over time going to degrade that insulation. Eventually will probably find its way into the property as water. So that's too much insulation. There's a particular software package called Hwb, W-U-F-I. If you're interested in wood fibre and you buy from a natural building material, I think, I forget what they call it, mae'r. I think they do lime insulation down in South Wales. The ecological insulation company, or there's another company down in Exeter Way that does this. They would usually do the Hwb calculations for you and tell you how much insulation is safe to put on your property. I found that usually the figure that I get back is around about 100 millimetres. If you have a slightly thicker stone wall or a thinner stone wall, it might be slightly more or slightly less. But it is important to check that and not just add massive amounts of vapor open insulation inside the property. Again, an energy efficiency consultant or the material suppliers should be able to help advise you on how much is too much in that case. Let's consider the financial side of this. Working out the financial payback can be complicated. And if you reduce the heat demand by 50%, it doesn't necessarily mean that you'll see a 50% reduction in your bills. What tends to happen is when heating bills are really, really high, people kind of put up with slightly colder, damper, more unpleasant buildings. You might have this thermostat in your community building set to 17 because it's prohibitively expensive to have it at 20. As soon as you've actually insulated your building and your running costs have come down, you'll whack the thermostat up because everybody wants to be warm and comfortable. And we want our community spaces to be warm and comfortable. That also makes, calculating the sort of reduction in actual running costs quite difficult to calculate. You could ask an energy efficiency consultant. You could ask for an energy survey. Again, do energy surveys through the Egin program, and there's also other government grants available for energy surveys. Or if you'd have a look on the Community Buildings Hub website, there are some self-help articles on there to help you work out some of those things. But if you spend £3,000 a year on heating and you somehow work out that adding loft insulation will save you £1,000 per year, and the insulation costs £6,500 to install, then you've got a 6.5-year payback period for that particular insulation measure. So if you pay for it yourself, in 6.5 years' time, you will have got that money back, and then for however many years the community building stays open after that, you'll be saving an extra £1,000 per year. Usually, loft insulation has by far the quickest payback period, as we saw from my example earlier of 300 mil of wood of rock wool. The amount of energy we use went down from roughly 5,000 watts down to 150. So it will have by far the fastest payback period. Usually walls has the second quickest, but where we see 6.5-year payback periods for loft insulation, we might see a 20 to 30-year payback period for wall insulation. And then usually floor insulation has, such a long payback period that we sort of ignore it and just assume that it's a comfort measure, really, more than a financial measure. But obviously, if you're lucky enough to find a grant to pay for the insulation measure, you don't really have to worry too much about the payback period. It's instant because someone else is paying. But you will have to convince the people giving you the grant that this is a worthy measure. And so it's still important to calculate the payback period and to try and convince them that it's a worthwhile measure for them to be investing their money into. So you may want to prioritize some things such as loft insulation if you're applying for grants, or potentially combining loft and wall insulation if the grant is large enough, so that the overall payback period is low enough to convince the grants people that it's a worthwhile package of measures to do in the property. Probably if you just went and asked for floor insulation by itself, they'd have a bit of a giggle and then say no, because the payback period will be so long. But you could potentially, with floor insulation, combine it with adding maybe an underfloor heating system. Then the cost is part of a larger measure of works, which might help convince them that it's a worthwhile thing to do. How much does it actually cost to externally or internally insulate your particular community building? It's really difficult to say because there's so many factors, like what is the wall type? How high is the wall? Do you need scaffolding? What's the final finish of the wall? If it's inside, is it lime plaster? Is it pink plaster? Is it plasterboard? If it's external, is it some sort of render? Or do you have to, if you're in a national park, add a stone or a brick cladding back onto your building? So it's really, really difficult to gauge it exactly. What I typically do at the start of a project with a community group is to look at a few websites. If you just Google how much does internal or external wall insulation cost to install, I found an article from Green Match, which has rough costings, and another article from Checkatrade, which will give you some sort of very, very, very rough costings, which you can use to sort of, look at the initial budget for the project. But as soon as possible, really, I would encourage you to go to a local builder to give you a formal quote, and then use that formal quote as the basis for any grant application that you make. Because obviously, if you go to Green Match and it tells you it's going to cost you £10 per square metre, you measure all your walls, you ask the grant agency for £10,000, you go to a local builder, and then he starts listing all the problems that's going to happen during the project, and he gives you a quote for £25,000. Well, you've now got a big hole in your finances. So use online sources to give you rough initial ballpark figures, but as quickly as you can, try to get some formal quotes and then base your grant application on those formal quotes if you can. I do get that that's very difficult to do. Local builders are very busy. Difficult to get prices off of them. There is, again, an article on the Community Buildings Hub on some strategies for obtaining quotes from local builders. Things like go to your local builders merchants and ask them who they'd use, because they know who comes in and buys insulation off them. And they want the people who are doing that to get more work. They might be able to give you a list of people to contact. And there's other tips that you can use there as well to find local builders to give you that initial quote. So just a quick note on thermal bridging. Sorry about the slightly complicated example here. What we have on the left is an uninsulated wall. In the middle, we've added 100 millimeters of wood fibre to this wall. And then on the right, we've come up with a solution to deal with thermal bridging. In this particular example, this is looking top down on an outside wall of a property, of two properties, with a party wall in between them. Okay. So in the uninsulated example, it's 20 degrees inside, it's 0 outside. And this particular software will tell you what the surface temperature of the wall will be. And in this case, 20 degrees inside, 0 outside, solid stone wall. The surface temperature of the wall is 15.2 degrees centigrade. So if you put your hand on that wall, it's going to be cold. Probably going to, over time, develop potentially damp problems if the room's not kept at 20 degrees and the wall surface temperature goes below 12 degrees. You'll start getting damp buildup on there. But we can also see that in the corner, point D, the temperature in the corner there is 15.6. So it's slightly higher than the temperature of the wall itself. And this is because it's pulling in heat from the party wall, which is internal to both properties. And it's actually, the temperature there is slightly higher than the rest of the wall. In the second example, we've added 100 millimeters of wood fibre. The surface temperature of the wall in point G, in the middle one, is 19 degrees centigrade, nice and warm, nice and comfortable, no danger of any moisture building up there. But in the corner, because heat wants to find the easiest route out, and the party wall is now the easiest route out for the heat because you've insulated the rest of the wall, more heat is actually being pulled out through that point. And so the surface temperature there has dropped to 14 degrees, which means if the temperature of the room dips below 20, maybe below 18 degrees, there's a potential for water vapor to start condensing in that corner. And that's where we typically see mold starting to develop in the sort of edges and the corners of the room. And one easy solution to this is to basically just put what we call return insulation. So bring 30 to 40 mil of insulation into the room to basically make it harder for the heat to escape through the party wall. So in the example on the right, exactly the same wall, exactly the same party wall. We've now added, I think in this example, 40 millimeters of insulation coming back up the wall. And we can see that the surface temperature in points A and B is 17.8 and 17.9 degrees centigrade, which means there's no danger of condensation and mold growing in those points now. So it's not going to make a massive difference to the running cost of the house or the community building, but it is going to make it slightly more comfortable and also reduce the risk of moisture and mold building up in those corners. So where you have a party wall like this, I would always recommend having a little bit of return insulation just to solve that particular problem. So I just want to give you a quick example of a building that I've worked in. This is Capelbach in Trawsfynydd. Initially, Scotch Baptist chapel, which was taken over by the local WI in the 1980s, later became owned by Cor, maybe on Prysor, of which my dad is a treasurer and I'm a member. And so this particular group was looking to redevelop their property. It was in particularly bad shape. This is the kitchen in the rear of the property. We can see plaster is peeling off the wall because so much water is coming in. A layer of concrete plaster has been applied, acting as a barrier to that water. So the water is just sticking there, staying inside the wall, slowly breaking apart the plaster, and then finally the plaster just fell into the room. So we stripped everything back to bare walls. We then started applying wood fibre. We got our Hwb analysis done, and that determined that 100 millimetres of wood fibre was safe for this particular building. What we're doing is we're putting a small thin coat of lime plaster on the wall first, behind the wood fibre insulation, pushing the wood fibre into the lime plaster, and then Medi, the builder who actually did this work for us, is then applying mechanical fixings through the insulation into the wall to hold it in place. The lime mortar acts as a binder, sort of binding it to the wall, and the mechanical fixings also help secure it to the wall. There's a detail here. This is an internal wall between the main part of the chapel and the kitchen in the rear, where we've got a potential thermal bridging problem. We can see in the right, there's a large stone wall. If we hadn't have put a little bit of insulation on the inside face, heat would have just escaped up through the stone wall, up and out of the property. So we applied 40 millimetres of wood fibre on this internal wall just to stop that thermal bridging happening and stopping condensation from building up on this wall. And then we've put loft insulation in, the bit in orange there above the kitchen. And then we put a little bit of synthetic insulation against some problematic parts of the wall, and we applied a tanking membrane as well, just to get rid of some of that moisture. But the rest of the entire property is all wood fibre insulation, all natural materials, all easily recyclable. Yeah. This is the entrance to the chapel. There was a sort of a little lean-to that we pulled out to restore it back to how it was originally. And then we started applying wood fibre insulation up the wall, again, 100 millimetres of it all the way up. So carried on applying wood fibre insulation all the way up the walls. A little bit of Kingspan with plasterboard on the sloping part of the roof. I think we put in total 100 millimetres of Kingspan in there. And then loft insulation up in the flat part at the top of this. So keeping a nice continuous layer of insulation all the way through the building. The walls up through the sloping roof, up into the flat attic bit, one continuous layer. And then we also added 30 millimetres, which was the bare minimum we could really without causing issues for wheelchairs and access and so on into the building. And then a little bit of 22 mil chipboard on top of that, and then a flooring material on top of that. So we added about 50 millimetres in total of height onto the floor. So we've got a nice continuous layer of insulation all the way around without any gaps at all. Once that was done, we applied a layer of lime plaster because, again, lime is breathable. It allows water vapour to pass through. So the stone walls allow vapour to pass through it. The wood fibre allows vapour to pass through it. And the final lime plaster coat also allows water vapour to pass into and out of the building. You can also see an example on the right that we've also put insulation in the reveals, so that between the wall and the doors and the windows, that's all been fully insulated as well to keep that continuous layer of insulation all the way through. And then finally a coat of paint, and yeah, the building's back looking nice. Probably looking closer to how it originally looked when it was a chapel, when it would have been whitewashed, compared to the horrible blue and other coloured paints that had been applied to it once it had become a community space. You can find more details about insulation and about some of the other things I've referred to here on the Community Buildings Hub. The link is there. I believe it's also in the chat. But if you also just Google Community Buildings Hub, DTA Wales, you'll find the link to it. there's an article on insulation, there's an article on other building interventions, heating systems, so on, where you can find grants, how to calculate carbon and payback periods, which are quite useful when applying for grants, as well as many other topics that might be of interest to your community building as well. That's the end of my presentation. Chance for you to ask any questions you might have about insulation. I'm also interested to know if any of you have actually insulated or applied insulation to your community building, and if that's made much of a difference to your running costs. So over to you.
There is a question in the chat
great.
About one of your slides, the one on costs.
Okay.
It's just asking that there's one sentence where it says that you might find that adding 100 mil of insulation as opposed to 100 mil is still cost effective. So
I apologise. Yes, I mean adding 100 mil of insulation, that should read, and I will change my slide, 25 millimeters, the bare minimum. Is still cost effective. So we might sort of look at it very logically and say, well, 25 millimeters gives us the most, effect for the amount of money we've spent. And so that's what we should do. But once we add in the cost of labor, the fact that thicker layers of insulation are often priced slightly more competitively than thinner ones, and we add all of that up, even though the extra 75 mil of insulation isn't having quite as much effect as the first 25 mil, it still makes sense to do overall. And it's sort of future-proofing the building a little bit as well, because once you've put 25 mil on, you'll find it very, very, very difficult just to justify adding any more. So consider, could I do a little bit more here? And is that worth it? Even though on paper, maybe it doesn't make sense, maybe in the sort of thinking about it long term, and maybe if you're considering getting someone else to pay for it through a grant, it might actually be worth adding a little bit more than you would otherwise have done. I'll often go to a builder for a quote, and they'll walk in and they'll just say, oh, 75, 50 mil of insulation is what you need here. And I've got to sort of say, well, they're correct. That is what will probably give them the most effect for the amount of money you're investing in it. But thinking about it long term, thinking about it in terms of grants that you could add to it, thinking about it that the cost of the insulation is only one small part of the measure, actually it might be worth being a little bit more, what's the word I'm looking for? Uchelgeisiol in Welsh. Ambitious. Being a little bit more ambitious might be the thing to do. Thank you.
Joanne has a question.
Yeah, Joanne, does that answer? Sorry about that. My badly worded slide.
Yeah, I have got another question though.
Of course.
So we've had an energy survey done, and they've recommended certain things for the building.
Yeah.
We're looking at the YNNI, is it YNNI? I don't know how to say that. That grant, and it needs 2 elements to qualify. So we're looking at solar panels as one, being the energy efficient resource. And I think, I can't remember the other thing, because they did come back to me, because I was like, I don't know whether I can apply. But another recommendation has also been the insulation. But my question is, if I put that into the main play area, will it make it hotter in the summer?
Yeah, that's a very interesting question. Yeah, thank you. There's 2 questions there. I'll just deal with the Ynni Cymru grant first, because I actually helped a number of groups get that grant last year, so I'm quite familiar with it. What they're looking for is that you generate electricity, but that you also use that electricity. Okay, so if you just ask for a grant for solar panels, they'll probably say no. If you ask for a grant for solar panels and maybe a heat pump, you've got a much higher chance of getting it, because you can show that you're increasing generation, but you're also increasing your consumption of electricity. And it's about creating a smart local energy system so that you increase generation and increase consumption at the same time. So my recommendation for community groups going for that grant is make sure you have both. They also allow you to put insulation in, but it's almost for them, nice to have. They want to see generation and they want to see consumption increase as well. I don't know what heating system you've got at the moment. If you've already got a heat pump, then obviously it might not be an option for you. If you don't have a heat pump, you might want to consider, if you're going for that grant, to ask for solar panels, but also maybe to ask for air conditioning units. Because it's a heat pump, it qualifies as a consumption device. In winter's day when it's really, really cold, but the sky is clear, so you may be generating a little bit of solar, you can use your heat pump to heat your property then. And you don't necessarily have to remove whatever your existing heating system is. So you can use the heat pump when it's a sunny but cold winter's day. You can use an existing heating system if you wanted to when it's cloudy, overcast, and you're not generating any solar at all. But you do need both of those things. You need generation and consumption. So I would look at either heat pumps or air conditioning units, which might help with your second question. If the building starts overheating, you've got solar panels, which are going to be producing the most heat, most electricity when it is hot. And you've got an air conditioning unit, which you can potentially use to cool the building. That might also help balance that out. But
would you need the heat? Because they replied back, I can't think who it is now, but they replied back saying that the air conditioning unit wouldn't, well, they didn't think it would qualify under the thing because it's not energy efficient, like if you're using a lot of energy.
Yep. No, it's fine. I've included. Was it any company that gave you that recommendation, or was it someone else?
I'll let me look it up now, and I'll.
Okay. At least one of my community groups did ask for air conditioning. It is a heat pump, so it qualifies as a heat pump. So I would query that, but I know it's difficult because you're having to have a somewhat technical discussion with the grants person.
I'm sorry, not the grants people, but the people who did the because I asked the question, I said that will the insulation make it hotter, and then they came back and said about having the air conditioning unit, but it might not qualify, something like that. I'll have to find the email.
No, I've applied for air conditioning units as part of the Company grant, and they were approved. So in fact, I've done a big project in Barmouth, and the heating there is now entirely air conditioning units, and that was an Company grant. They've also got a massive amount of solar panels. But
how does that work? Sorry, within it. So does it act as two things? Does it blow out heat and air conditioning?
Yeah. Essentially, it runs in reverse in the summer and produces cold, and it runs the other way in the winter and produces heat.
I see.
So
okay.
Yeah. So it's a heat pump. It absolutely does qualify. Now, with insulation, it can potentially make a building warmer. Again, if you're putting external insulation, so insulation on the outside of a building, it tends to have a less of an effect because it's keeping heat out of the building that otherwise would have flowed in through the walls. And the wall itself will also act as a little bit of a heat sink. If you add internal wall insulation, it certainly can cause the building to get warmer because it's essentially keeping the heat in, particularly if it's, I think you said it was a nursery, was it?
It's a children's role play centre, not for profit, but it's a tin, kind of like a tin building. And we've got false tiles, so we were thinking about insulation on top of the false tiles. But it does get really hot in there in the summer.
Yeah, indeed. Yeah. It's in building, I'd expect. It conducts heat really, really well. You might want to consider doing external insulation to sort of stop the heat getting in. But if you do internally insulate, you either need to dramatically improve the ventilation so that you're sort of circulating the air and getting that hot air out, or you might want to consider air conditioning units just to give a little bit of cooling help as well, particularly if there's already a problem even before you've started insulation. But like I said, it will qualify as a measure under any company. I know because I've just done one. So
have you got your email that I can just forward you the info? Is that okay?
Yeah, definitely. Yeah, it's let me put it into the chat.
Thank you, because I really don't know anything about this.
Yeah. Are you have you asked any local sort of solar installers for quotes for that? Or?
No, not yet. But I don't know whether they did they do that? They might have done a breakdown. I can't remember now. I'll have to
in the energy survey,
yeah. I might have to look back through it because
we
had that done through a grant, and it came back. It was quite a comprehensive document.
I would look for a local air conditioning unit installer. I know a lot in North Wales, but whereabouts are you based?
Yeah, South Wales.
South Wales. I've posted my email there. If you send me your details, I'll have a quick Google, but I won't have any personal knowledge of whether they're any good or not, unfortunately, because I haven't dealt with any companies in South Wales. But I can at least send you some links to some example companies. Just ask them if they'd be willing to give you a quick quote for a grant. You only need to find one and then use that, add that to your
I think it did say, I'm sure it did say a price in there because I was scanning it. I mean, I didn't read the whole document, I'm not going to lie.
Yeah.
But I was scanning it and I'm sure there was some prices in it somewhere. So I'll send you that if that's okay. And then
fantastic. Yep, of course. Yeah, more than happy to help with that.
Thank you.
Yeah, but it is a good point. If you do internally insulate a property, you can potentially have a warmer building than you would otherwise like in the summer. And it's important to sort of consider these things in the round. But I would sort of also say that typically the bigger problem we have in Wales is too cold of a building rather than too hot of a building. But it is important to consider both aspects. So thank you.
Just to note that we've gone past 2 o'clock.
Yeah.
We also have 2 questions that people have added in the chat that haven't yet been responded to. So would you be happy, Elvid, to stay on a little?
Of course, yeah. More than happy to.
Others wish to stay on, you're welcome to. Or until we've maybe covered off those 2 questions, or
happy to, yeah.
Okay. So one of them is, what are the paint types that maybe are concerned with damp problems on insulation?
So in the example I gave of wood fibre insulation with lime plaster, we're sort of, the wall is vapor open, the wood fibre insulation is vapor open, the lime plaster is vapor open. If we just went and applied a typical synthetic paint onto this, that would not be vapor open. So the last layer we'd have would actually be blocking moisture movement through the wall. What can then happen is water still wants to come through, and it'll bubble up and the paint will flake off. We see this quite a lot in old church buildings that have been white, have lime on the walls and have been whitewashed, and then they get a coat of synthetic paints, and then eventually the paint starts peeling. So we need, again, a vapor open paint type. There's several different types. Mineral paints usually are better, but you just want to ask whoever's supplying you with paint that it's a vapor open paint. There are some, expensive paints that are, very, very, very vapor open, but usually some type of mineral paint that's specified as being vapor open or that has a high degree of vapor permeability is usually the best one to ask on that sort of a build-up. If you're using more synthetic materials like Kingspan, plasterboard with pink plaster on top of it, I'm less worried then, because all of those are vapor closed materials anyway. So you'll have to deal with your potential moisture problems in different ways if you're using those sorts of materials. And then in that case, you can just slap a coat of Dulux on or whatever you might want to use without worrying too much about what type of paint you want to use. Hopefully that's answered that particular problem. And then Sheridan, is it possible to insulate above suspended ceiling tiles, or should we need to replace the ceiling? Again, this is quite a difficult question to answer because it depends on how much weight that particular ceiling, suspended ceiling type can take, and how much insulation you're adding to it. If it was a new suspended ceiling, you would ask the installer, what's the weight rating on the ceiling, and they'll be able to give you the figures. If it was done 20 years ago, probably the builder who did it originally isn't around anymore, and so you might not know how strong that particular suspended ceiling is. You could ask a builder for some advice. You could maybe ask a structural engineer, but that's getting quite expensive. Or what I would probably do is try and find someone who actually installs suspended ceilings, just give you an assessment of, is it sort of solid? Is it strong? Are you likely to have potential problems with it? With the caveat that they are motivated to tell you that it's not. So you just have to, bear that in mind. But the other thing you could do is, don't over-insulate that area. Don't put 300 mil of insulation above it. The ceiling tiles themselves are reasonably good insulation materials already. They're usually some type of polystyrene or a synthetic material. So maybe, if you think you can take the weight, maybe put 100 mil and maybe don't put much more than that. Or if you've got maybe a small meeting room with the same ceiling type in it, maybe try and insulate that one, leave it for a little while, make sure that you're not getting any sagging or any problems with it. But again, I'd be hesitant to do that without maybe consulting a builder or someone who's actually done the suspended ceilings who can give you a little bit of advice on it.
Great, thank you.
Yeah. Sorry, it's a difficult one to answer, particularly if it's an older suspended ceiling.
No, it's old. It's 1972. We put it up there.
Yeah,
before my time. They've been up there. They've been up. I've never seen it. They've been up there and installed the fire alarm system and such.
Yeah,
so they can get up and walk around up there. But
I got no
idea what weight it'll take.
Yeah. Well, the fact that someone's walking up there is probably a good sign that it's in reasonable nick.
Yeah.
But in that case, a structural engineer is probably your best bet, although they're not cheap, unfortunately.
No.
One thing to also watch with particularly old suspended ceilings is, have you had the tiles tested for asbestos?
Yeah, they've been done.
They're okay, good. That's the only other thing to watch there.
Yeah, we had to replace all the tiles actually.
Okay, yeah. So they were asbestos tiles, were they?
They were in some of them, yes.
Yeah. Okay. Fantastic. That you've replaced them.
Yeah.
Not fantastic that they were asbestos.
No. I understand.
Hi, Elvid. Hi, Elvid. My name's Barry Smith.
Hi, Barry.
Pembrokeshire.
Yeah.
Two things. I'll explain. I joined our local community council 6 months ago and started looking at solar panels, etc., etc.
Yeah.
God, I wish I hadn't, because it's a bloody nightmare, to be honest.
Yeah.
Two things. Number one is energy surveys. You said Eggin actually do them. What is the cost?
Matt, do you want to?
Yeah, hi. So although we have been offering energy surveys, we are unfortunately drawing that to a close because we've been running Eggin since 2023 and we've been offering them for free. But the budget for that basically has been exhausted. So right now we're not able to offer anyone free energy surveys. So, but we do just ask people to, like you say, there are places which are offering grants for these things that they seem to come and go. We don't have a comprehensive list of them, however.
That's my next question. Yeah, it is a complete nightmare in Pembroke. Well, just for Pembrokeshire, I think I'm up now to about 19 different associations offering grants. Trying to get a detailed list and say, right, these are the people that you can contact. Okay, Eggin is one, and YNNY is another one. There's a lot of them, but surely that there should be a comprehensive one-gun approach, really, where you can actually say, right, these are the people that you can actually contact, because it's just a complete and utter nightmare. And the thing is, bear in mind, a lot of people in communities are doing this for nothing, but they're spending a huge amount of time trying to find the appropriate people and getting hold of them. And then they say, well, we've run out of money and everything. To be totally honest, I think it's a little bit of a shambles. If I'm from a sales background, surely we need a joint approach here to say, right, these are the people who can offer this, these are the people who can offer that, and so on. At least I would save a lot of community people that are working for nothing, you know, the amount of time to try and find the processes. But yeah, it's a nightmare.
I do agree with the sentiment, and having done a fair number of community projects now, you know, you've got to apply for multiple grants. There's usually deadlines, and usually, you know, the deadlines are very, very short to actually deliver the project, and it's stressful and it's difficult. The only positive is that it is free money if you can get it, right? And I've found that once I've done 1 or 2 grant applications, I normally have everything I need to do further ones. So once you've sort of, you know, they usually ask for your policies on, you know, your Welsh language policies, any of this, that, the other policies. And you've got to go off online, find someone else's policy, rewrite it for yourself. Once you've got that pack of things that they typically ask for, once you've actually applied for a couple and you know what sorts of questions they're asking, it does get easier. And the advantage of having so many different organizations offering grant is, you know, if there was only one and they say no, you're a bit stuck. Whereas at least, you know, if you've got a diversity of different groups offering grants, you can try different ones and hopefully find one that sort of matches what you're trying to do with your building. But I do get the frustration. And just in the Community Buildings Hub, there is an article on there about different organisations that find grants, and it's to find grants with. And it isn't easy. I do agree.
It's not actually putting the pack together. It's actually getting, and the number of people I've spoken to say, look, can you just send me a blank application form so that we can actually look and tick the box? You know, they say, well, no, you've got to apply. And I said, well, you know, there's no point applying if you haven't got all the information to hand. So, you know, I don't know. I'm assuming all this is funded by the Welsh Assembly and Son, but it is a bit of a shambles, if I'm going to be totally honest. And
it's a mixture of different funding pots. One of my projects was funded by UK government, one up in Blaenau Ffestiniog. The one in Trosfynydd, actually, that was levelling up funds, again, UK government. The Ynni Cymru one is Welsh government. But you've also got private foundations like the Tesco Foundation, the Asda Foundation. And so, yeah, there is a lot of ones out there. And yeah, but I do find they tend to ask for the same things, usually. They want to know what you want. They want to know how much. They want to know payback periods. Quite a few of them want to know carbon savings because they might have an environmental aspect to this as well. There is another document on the DTA Building Hub on how to sort of work out carbon savings. And it is frustrating and difficult. And getting an energy survey gives you most of what you need for grant applications. Well, that's why they're really good. But it's just quite difficult to get them. They were quite popular a few years ago. Coal fields is one.
Yeah, that's another one. Yeah, I've got that one. What is the cost of a commercial energy survey?
I'm not sure. I'd have to ask around. I would expect.
Are you looking at hundreds or thousands?
Yeah, I would expect somewhere between maybe 750 and 1,500. But don't quote me on that. That's a guess.
No. What I'm saying, if it's £100, that's fine. But
yeah,
when you look at it, if you look at a community side, you've got to set aside £1,000 to get the energy. You know, that's the reality. Reality side.
I don't know if I can help, but we had an energy survey done with the coal fields, and it didn't cost us a penny.
Well, the thing is, where I live, we've got no coal. We've got oil, but we've got oil, but you know, but we don't have any coal, sadly. But that's the thing. No, Elvin, thank you very much. Very, very informative. Thank you.
You're in Pembrokeshire. You're in Pembrokeshire. A while back, I did hear some whisperings that Snowdonia National Park was offering some sort of small grants. So it might be worth checking with the Pembrokeshire Coastal Park just to see if they have any sort of small energy grants available.
Yeah.
Similarly, you know, the project in Trosfynydd, the now long closed nuclear power station, they gave out £500 mini grants. That would have been, you know, a good chunk of what we'd need for an energy survey. So I wouldn't necessarily use your own money I would try and find a small grant to cover it.
Yeah.
But that's more paperwork.
the definitive thing would be to say you've got 20 funders, okay, and then you just go down the list, don't you?
Yeah.
And I think it's getting that list together is the difficult side, like, you know.
Yeah. Do have a look at the grants document.
I will.
Yeah, might help you there.
Joke about.
Let's go in the chat. I'll put links to those 2 documents that Elved's mentioned in the chat there.
Thank you, Matt.
Okay.
Were there any other questions?
Yeah, I've sent you an email with both of the yourself and there was an Egan. Is it Egan? I sent it to them as well. So
lovely. Thanks, John. Thank you. Great. Okay. Do you want to finish us off, Matt? Or
just finish you all off. Just to say that next week we can have more of Elved on Tuesday at 1 o'clock. Elved's going to be down in a building down in Cardiff, community building there, to walk through and kind of show you some actual video and live stream video, and talking with the people who run that building at Oasis. To talk about their retrofit measures and so on. So it's going to be an interesting session. If you're able to join us, it'd be great to see you there. So it's next Tuesday at 1 o'clock. I've put a link to the sign up also in the chat there, just if you scroll up a little bit. It's on our Eggin website. Learning from the live stream, learning from the retrofit of Oasis's building. So looking forward to that. But thank you, Elvi, that was great. It's been really comprehensive and clear, I think. So thanks for all your advice and input there, and hope it's been of help to those that have joined us today. Thank you, everybody, for coming.
Thank you very much. Thank you.
Really good. Thank you.